All right, today, what are we going to be covering today?
Dilations.
That's right, dilations. All right. So, by the way, dilations. There are two things that you guys need to understand about dilations. Okay? All of the other transformations have either moved it left or right. What do we call it if you move it left or right or up and down? You slide it left or right or up and down. Which one is that called? Translation, all right? What happens when we flip something across an x-axis, right, or y-axis? Reflection, all right? What happens if we turn something? Rotation. Now, all three of those transformations don't change the size or the shape. Dilations is the one transformation that changes the size of it. Not the shape of it, but the size of the shape. So, if you have a triangle, you'll be making either a bigger triangle or a small, that will be similar in size. So if you guys would look right here at this problem, what we're going to do is it says this has been dilated by a scale factor of 2. Now there's two different types of scale factor. If the scale factor, I'm going to call x the scale factor. If x is greater than the number 1, if it's greater than 1, then we're going to have what's called an enlargement. Okay? Enlargement. If it's greater than 1. However, if x ends up becoming less than 1, but it's still greater than 0, then we have what's called a reduction. If x is equal to 1, if the scale factor is equal to 1, that means it doesn't change its size. It doesn't change its size. Just, that would be called a congruent transformation. Congruent meaning it does not change its size nor its shape. Right? So what are the three different types of dilations? One is called an enlargement, one a reduction, and the last one, if x is equal to 1, that means it doesn't change its size at all. Okay? Now, this one we have a scale factor of what? We have a scale factor of 2. So if it's dilated, all right, and it's dilated at, keyword, at the origin, that means all you have to do for your new x and y coordinates, if the scale factor is 2, you just got to multiply your x value and your y value by 2. So what's double 7? 14. Double 10. Boom. Double 4? Double negative 6. Double negative 2.
I thought a negative times a negative was positive.
You're right. A negative times a negative is equal to a positive. We're just doubling it. All right. What's 3 times 3? I'm sorry. Double 3. Double 3 is 6. I said the wrong thing. Double 3 is 6. 3 times 3 is 9. All right. But what did we just do with all these? We just simply doubled them. What I'd like you to do now is I'd like you to plot them on your paper. Plot those right over here. All right? So we're going to plot a 14 and a 20 right there. We're going to call it A prime. We're going to plot an 8 and a negative 12. 8 and a negative 12 right here. We're going to call it E. And last but not least, we're going to do negative 4 and a 6. We're going to call it C prime. Now, what I'd like you to do is carefully connect those points with your straight edge. Now I want you to pay really close attention to something. What I'm going to do is I'm going to draw a dotted line from the origin to our new point. So I'm going to draw it to A prime. I'm going to draw it to B prime, and I'm going to draw it to C prime. Now something that I want you to notice, and it's harder to notice with B prime or C prime, but I want you to notice that look what happens. A prime passes through what point? It passes through our original point A. So can you guys see this distance right in here? And then Can you see this distance? Can you guys see how these together make a prime?
Yes.
So that distance right there has simply been what? It's simply been doubled. It's been multiplied by 2. What I want you to see is that this segment right here is the same as that segment right there. And by the way, whenever you're drawing these from the origin, your line will always pass through the original point to the new point. Okay? So what we're going to do right now is we're going to go down here, and we're going to start right here from C, and we're going to dilate the image, and our scale factor is going to be what? What's our scale factor? Ooh, so that's definitely going to be a reduction. Okay? So that's going to be a reduction. So if you guys would, please, carefully get your rulers out, okay, or your protractor. Now I'm gonna make my line a little bit thinner right here. So what I want you to do is from the center of C, draw a point to each corner of the square. So each corner, what I want you to do is very carefully, I want you to draw a segment to the tip of each corner from the center. I know mine's not perfectly in the center. Try to get yours perfectly in the center of C. Now, what I'm going to do is I'm going to get my ruler out, and I'm going to measure to the best of my ability, like each segment. Oh, let me do that. So right now, we're going to measure this right about. It looks like it's right about at 8 centimeters, around 8 centimeters. So what I want you to do is go to right here where it says 2 centimeters. Well, I know yours is going to be different than mine, but this is where I'm going from. So whatever your measurement is, what was this original? This was about 8 centimeters. If I take 1/4 of that, that's going to go down to what? 2 centimeters. Because 8 times 1/4, by the way, 8 times 1 is 8. Divided by 4 is 2. So right here, what's the distance from right here to right there now? That's, for me, that's about 2 centimeters. Yours is going to be different because your paper is different than my paper up here on the screen. So right now, to the best of your ability, I want you to simply plot a point about 1/4 of the way of the total. Now, what I want you guys to do, I'm going to go ahead and close this out, is draw carefully. Do you guys see this line right here? It's straight, right? So from right there, carefully draw a straight line until you reach the next part. Alright, so what I want you to think about right now, can everybody see? All I did was basically just like you go from here to here, I'm just drawing a straight line across, and there's my next point. Now, the next thing I want you to notice is, you notice how this goes straight down on the side of that square. Okay? So, imagine you had a point right here, and you had a point right here, which face is similar to this. Whatever this distance is 1/4 of the distance from here to here. Now, if I go straight down and put a point, I want you to do the exact same thing right here. You're going to go straight down right there. And what are you going to do? Put a point. Right there. Next thing. You guys see this length from here going straight down to right there. So going straight down. What I'd like you to do is carefully go straight down right there. I think I went a little bit too far, but that's okay. Right here, to the point. And last but not least, this segment. Hopefully you can start seeing our new image. can everybody see this square right in here? Each side of this square is 1/4 of the original length. Each side is 1/4 of the original length. Okay? So right now, whatever this length is right here, this side is 1/4 of it. So we basically, can you guys see how this was shrunk down along those lines? Okay? Every single point, imagine like I took this point and slid it down to 1/4 of the size, 1/4 of the size, 1/4 of the size, 1/4 of the size. And that is your final image. Okay? We just took that and we drew a dilation of the image with a reduction of 1/4. So, right here, what's our new scale factor? 1/2. So what you're going to do is you're going to carefully, from the center of C, this one's going to be easier, because it's easier usually for students to have something than to quarter something. Don't worry, nobody's going to be drawing a quarter. Do your best. This point, and this point right there. All right, what's the scale factor? The scale factor is 1/2, which is also considered to be a reduction. Okay. So what are we going to do with each side? We're going to take everything, we're just going to half it. Okay. So right now, I'm just going to do my best with my ruler. I mean, you guys can kind of eyeball this if you want. All right, I'm going to take my ruler right here, line it up to the best of my ability right there on that line. Basically, it looks like this is 8 centimeters, so where am I going to put it? Around 4 centimeters, okay? So right here, I'm going to say right there. There is pretty close to 8. We'll put a point right in here. All right, so right there, that point is halfway between. So I'm going to go over here, measure it. Looks like that is about 11. About 11.5. Okay, 11.4. So what would that be if I took 11.4 and took half of it? What would that be? Half of that. 5.5 would be 11. So about 5.7. Yeah, about 5.7. So right there is about 5.7. So I'm going to put a point right about in there. Now I want you to note what I'm going to try to do here. You guys, I want you guys to walk over. You guys see this right here, that side of the triangle? I need to try to my best of my ability, I need to try to make those parallel to each other. So I'm going to say that these lines are relatively parallel to each other. So make sure that this side is parallel to this side. Your best to kind of, this is the halfway point between S and C. That's about halfway. Next thing I want you to do is I want you guys to draw the new S prime to T prime. See how nice and straight that is? That should make your job really, really, really easy. Well, by the way, you should be able to go what? Straight across. So if your line looks like this, that's not good. If it looks like this, that's not going to cut it. It's got to be what? Straight. Right there. Okay. Because are these triangles going to be similar to each other? Yes. The sides of our new triangle are going to be half the other. And here is our resulting image. So one thing I forgot to do last time, I want you to label it. That's R prime. That's S prime. That's T prime. So we have R prime, S prime, and T prime. Okay. And the other one, I forgot to do this. I'll go. Oh, this one didn't have letters, so never mind. Okay. So there's R prime, S prime, and T prime.
I like that.
All right. All these sides are half of the original. The first one, everything was a quarter. All right, moving on, everybody. Moving on, right here. By the way, let me zoom out. We're going to look over some instructions, and we are going to do problem number 6. That's it. We're just going to do problem number 6. You'll be doing the rest of these on your own. It says, determine the scale factor. So one of the things you need to find is the what? Scale factor for each dilation. Determine whether the dilation is an enlargement, a reduction, or a congruent. By the way, none of these are going to be congruent. Okay? They're either getting bigger or they're getting smaller. Okay? So what we're going to do is we're going to find the scale factor, and we're going to say whether it's an enlargement or a reduction. So we're going to go ahead and zoom in on number 6 so you guys can clearly see the image. Okay? Now it says triangle EFG is a dilation image of triangle ABC. So ABC, is that the big triangle? Okay. Supposed to be ABD. Hold on. Yeah, they messed up there. ABD. EFG should be a dilation of ABD. So is ABD the big one or the small one? Small. And EFG is the big one, or the large one. So we went from what? We went from small to large. We went from small to large. So what type of transformation is that? That's an enlargement. So that's one of your answers. Okay? It's an enlargement. And I'll go back in there and I will change that. So right now, let's think about, what's the scale factor? How can we find the scale factor? So one of our answers, it's definitely an enlargement, and the next thing you need to find is the scale factor. So here's what I do. I look at a distance that I can easily measure, like this distance. And what's that distance from there to there? 4, right? That's a 4. That's a 4. And then I look at the same one that I can easily evaluate. So our new one is 6. All right? So, and if it's an enlargement, you put the big over the small, and that gets you a scale factor of 3/2 or a 1.5. Now, everybody, I want you to understand, scale factor is 3/2 or 1.5. Everything was multiplied by 1.5. So, what are each of these sides? They're 1.5 times bigger than the original side. Okay? So those are your two answers. Now, what if I switched it and said ABD is a dilation of EFG? Then it wouldn't be an enlargement, it would be a reduction, and the scale factor wouldn't be 3/2, it would be 2/3. That's all I'm asking you to do. All right? See if you can do the other 3/3. Good luck.